Good morning. We are going to see today how you obtain the state space form using CAMG and using the input from a bond graph model. So what you see on the screen right now is an electrical system here that we're going to use as an example. So the objective of this example is to obtain the matrices A, B, C, D matrices of the system, and also how can we send these matrices to a Simulink model. So that way we start from scratch with the system and we will end up with the matrices as well as with the Simulink model. Let's see how we have to do this. So we have the system in here, and what I would like to do is I would like to see that we build a bond graph model um, on the system in here over the system, and then we're going to use that. So let me just get a nice pen in here, red, so to make a difference in what we're doing here, the way we see this. In here, we could put a one junction for each distinct current here. And right there, this is for the current in this loop. And this will be for the, let's call it I1. And then we're going to call it I sub 2. And attach the step number 2 that we have in the procedure for modeling systems is to attach the elements that see those currents. So on the right hand side is obviously that this inductor here is an I element over here, right? And in here we have an R element. I am going to do this like this with value, in this case 1 ohm, right? The value of this is 2 hertz, 2 henries. Okay. Over here you have a voltage source, which is SE like this with value of voltage like that. Attach here this resistor over here. I am going to say this is the resistive element with value 1 ohm in here. And then you have this capacitor in here. This capacitor is a C element with value 1 farad. And in between in here, you can, so we are done with the elements that are attached to the one junction. Oh, we're missing one. See here? There's another I element over here, which has value 2 henries. The next step is to create the difference between these two currents, and we do it with a zero junction that we put like this, and this will create the difference I1 minus I sub 2. And the last step in our building of this bond graph model is to attach the elements that see this difference. And you can see there is an R element over here with value 1 ohm. Then there is the other element, which is a C element with value 1 farad. Okay, this is all we need to get CAMG working and to get this model into the software. So what we can do is perhaps they have this picture in here in a shorter scale in here so that we can refer to a little later. So one way of doing this is I could just use my sniffing tool from the from Windows, and I'll keep just this part in a window here that I can actually resize even if I need to. That will give us an idea of this. Okay, so let me do this. We're gonna close this, and we are going to go ahead and call the KMG software so that we can put this Bondgraph model into it, and that is going to be right there. So okay, I'll move this over here so that we have time, we have enough space to do what we need to do. So let me move this back in here. Okay, so here's we have this no, for a second, I think we have this. There we go. So we put this in new, and then we have the ability to draw. So here we're gonna. It doesn't matter in which order you enter it, but we are going to go from left to right. But like I said, it really doesn't matter how you do it. So here is the Bondgraph model. We don't have to use the same rules that we used to build it, because we are basically transferring the model onto the program. We don't have to follow any procedure like we did to the original Bondgraph model, because like I said, this is just transferring what we have already designed to be our system. So I place it in where I want each element, picking up from the menu over here, and I keep building my Bondgraph model. And then you have this one over here. We are almost done. We have the R element in here to go, and then we have one more C element, which no, this I element over here. There we go. Everything checks, everything is all right. Now it has the Bondgraph model on the right hand side, has not only the causal marks, but also has bone numbers that the computer has assigned. And it would be nice also to keep it in in another picture, just like I did the first one, so that we have so that we have access to it. Okay, so let me do that so that we can we can do that. Okay, so here I'm just going to go and say okay. Again, in this case, I'm going to keep it like this, because we want it for purposes of the simulation, for understanding what we're doing here. One thing that we know from the problem that we have is that the output is the voltage across this inductor. So in terms of the Bondgraph model, that output is E11. So keep that in mind, that E11 is our output. So E11 is what we are after. Okay, and that is going to determine the output to build the C and the D matrix. So what we need to do now is to go to the interface here and go with MATLAB and have the two programs shake hands with each other, and hopefully produces a nice set of M files that describes this BONDLAB model. What we are interested in this case is the CAMGSYM file, because that's the one that produces the state space models, which is what we're doing right now. So that is going to be this file right here. So in here we have, let's see if we can have the file. I guess we have our bone graft model on the right hand side, and we have this on the, on the left hand side, and we have the file on the right hand side. The thing that I need to do at this point is to make sure I define the Z11 as the output, and because otherwise our matrices are not going to be complete. So I'm just going to go and say E11, find E11. The computer has derived all the equations for all the outputs on the system. E11 is one of those. So what we need to do is, because it doesn't know which one you want and we picked it, now we need to activate these lines to create a row for the C and the D matrix. But very briefly here, what we have on this file is, let's see if we can give a good impression of this. In here it has all these are commented out because these are the parameters as well as the initial conditions, because we are not doing a time domain simulation yet with this, but rather we want to derive the matrices in symbolic form. So it gives you an idea what the inputs are. It gives you immediately the order of which the state variables are. So this is a vector that will multiply matrix A, and it will be in this order: Q3, Q8, Q11, and P so forth. And then it has the equations of the system. See, this is 1, then it's 2, and then it's 3. These equations are in first order differential equations known as the Cauchy form. From these equations, the computer, in this case CAMG software, has already arranged to derive the matrices and the equations for each one of the outputs. So we happen to pick E11, which will be a little, see, all the other ones are commented out, but this is the one that we wanted as our output. So if you run this, you immediately will get those matrices. So let's just go in here. As you can see, you have tell you what the inputs are, and tells you what the state variables are, and in here you have this okay, and then you have the matrices right there. See the A matrix and the B and the C and the D matrix, okay, this is what we want right now. I want to help you interpret this, and so what we're going to do is let's pick the different outputs, and I would move them to my I like to move them to the OneNote that we're using for writing in this in here. This is what we obtained from CAMG now for this model. See here. Okay, what this is telling us. What this is telling us is that on this, you see the computer is saying, look, this is this is the input, right? Okay, this is the input vector. It's saying your input is E1. So this is really the U vector. So this is like writing U is equal to like this is E1. And then see in here it says the state variable vector. This is state variable vector is this vector is like writing this PQ is that vector X for the state variables like this. What you are reading there is that this is Q sub 3. The second one is Q sub 8. Then you have this is P11. And you have this is P sub 4. This is your state vector. Okay? And it's saying your output vector, this vector Y, is equal to E11. Like this, see? This is important to know how to read the output of the CAMG software. So we are going to go back to, once it has been processed in MATLAB is what I mean. So this is the A matrix in here. And what I like to do is, again, I would go over here, and then with this I will cut this little piece so that we would be able to understand and put together my state space form. And so I'll go back to the OneNote where I am, and then I say, okay, paste this please. So that's the A matrix in here. What I'm thinking is it might be a good idea to, let's just move these things around a little bit. And do it down here so that we have enough space in here. What I'm seeing here for this is that this vector that is on the left hand side, the one for the derivatives, see, this is like this. This is equal to, this is dp, no, excuse me, dq3, let's just do it right. Which one is our, is this one, right? No, sorry, we gotta have the same color, otherwise we need the red one, right here. Okay, so this one is dq sub, this is dq sub 3 dt. The second one is dq sub a dt. The third is dp11 dt. This is what the computer is telling you. And the third one, this is dp sub 4 dt. Yeah? And then, let's see, let's pick again. We have this. And then the state variables are here's where we put our states. See, Q sub 3 This is Q sub 8. This is P11. This is P sub 4. Then plus, and now we need the B matrix. So let's go to the MATLAB side in here. And do you see the B matrix right there? B matrix should be, we do the same thing as we did with the A. Let's just take it from here. And we will move it to the one note over here. There we go. But in this case, we need to make it a little bigger so that it would coincide with our, like that. So this is the matrix B, and then you need to, it's multiplied by U, meaning this one here multiplied by SF1. So your form that you have for the state space model, for the state space here, this is like x dot, like this, is equal to the matrix A plus the vector x plus the matrix B as the vector U. This is what you have. So this is the state space model from CAMG, and now we have to go back to MATLAB to do the C and the D matrix. And let's just again collect that in here, and then we're going to cut it and then paste it onto the OneNote file in here. So there we go, and then we go and collect the other matrix, the D, and the D matrix is going to be also like this. Let's just pick it up from here and bring it to the OneNote so that we are able to put this together correctly. So what is it doing here? This is saying that the output, of course we have only one. Maybe we should have gotten a couple of them, but this is a voltage of the inductor. This is E11 is equal to the matrix this is the matrix, this Q sub 3, Q sub 8, P11, and P sub 4 plus, and then you have this is the matrix D multiplied by the SF1. And when you do this, you have actually done the second part of the state space, which is the output is equal to some matrix C multiplied by the vector of state variables plus the matrix D multiplied by the vector of inputs, du. Let's see, we get this correctly in here. SF1. See? So this way you have been able to read and interpret everything that CAMG did for you. One last thing, how do we put this into Simulink? Okay, how do we do that? In this case, Simulink is not going to take the Simulink block in the state space form wants to see the parameters on the system. So wants us to enter those values. So what we need to do is to put the values depending, according to our graph, to our picture, and those are over here. So what I need to do is I need the original model here that has those values. See, this one has the values in there, and then I need to relate those to this here. See the values in here. We need the one that has the numbers, don't we? Well, so we need to activate this. Okay. R2 corresponds to this one over here. So this was going to be a 1. And then you have C sub 3, it will be also a 1. And then you have I sub 4, which says 2, right? And then you have R sub 7, which is 1. Yeah. C sub 5, which is also 1. And then you have R10. What's the value? Is also 1. And I11 is 2. And this is 2. What happens in here is if we run the CampG software, run it again, watch what will happen. In here, CampG will put together a test run of the software, but with numbers now. It turns out that I didn't close the numbers here. Here we go. Now we are. So this is the A matrix is numbers now. The B matrix, so it's numbers. C also. Yeah. And what we have in here is it will give you also the transfer function of the characteristic equation. I'll give you the transfer function. So there is just one error message in here that talks about a command that has been changed on this new version of MATLAB, and we just need to put a comment to this line to get rid of that error message. Let's just do it. Let's see. Okay, there we go. These are the matrices, and this is the characteristic polynomial, and there is your transfer function for that particular output. Well, and if you want, CampG at this point is in the position to be able to do the root locus plot of this transfer function, as well as the body plots. One of them studies the roots of this characteristic equation in terms of a gain, and the other one is the response in the frequency response. So we could see how they look for this right here. So when you put numbers, you you are able to do this, and you get the impulse response, and of course it has the step response also, and it has the body plot and the root locus plots. So that comes all from the initializing these matrices and putting into numbers. But if you actually look this at the matrix A, if you look at B, if you look at C, and if you look at D, they are all in there. And we already know that that state space representative corresponds to this kind of equation. And see here, it corresponds to this. Yeah, both the A and B, as well as the C and D matrices. Okay, what that means is that because MATLAB shares the space, the workspace with Simulink, if you run Simulink, in the background, those matrices in numerical form already exist. See? So that's important, because when you run Simulink and we use the state space form, and we have just this output as we have defined it in here, the computer, the output that originated in CAMG will end up in Simulink. Let me show you here. It's giving us a little bit of a time delay. I don't know why, but it is doing that. Well, eventually Simulink is going to come up. And what I want to show you is that those matrices that you saw in the numerical form, there we go. See, if you open now a new model of Simulink for workspace, and there it is. There is a commonly used blocks. One of these is got to be the state space form, and if it isn't, then we're gonna look for it.
It's a
Okay.
continuous.
Huh?
Continuous blocks.
Yes. Right here. See? What happens is this block, and the way I have it in the background, it already has the outputs defined, and I need to define the input as well. In this case, I need to define it as a step input. So where would I see commonly used blocks? Where is the step input in here? I don't see it. I think we could just do it with the constant in there. See where the maybe it's in here too. No, we just use the we use this input in here like this. Let's just use a constant input in here. Just a step input of 1. And in here, I am going to get, because the state space form define the output, right? In here, I'm just going to, if I connect this over here, and I open in here, guess what's going to happen? The computer in here will will produce my output for the step inputting here. It's doing its calculations. And what did it do? It gave me an error, just a warning. And this is my the step for this particular inputting here. Do we have the impulse response in here? Sources. Sources is what I want. This is a constant source. This is what we wanted. Let's replace this one with that. Yeah, and see if we get any new result. Okay. Okay. Okay, so we run it. Warning says the model name is shadowing another name in the MATLAB workspace or path. Well, there we go. So we got the response there. But you could do it for other inputs that you want. In other words, your equations on your system are all there. And you could put the sine wave input in here, or a pulse generator for this. Let's just do this one. See, there's another input in here. Go up there here, and then we go over here, and this is going to give us the, what did we do? There might be an issue with this warning that we have, but the point is that you can get the state space model from ChemG all the way to MATLAB and Simulink, which is what we wanted to demonstrate with this presentation.